Concept? The cock versus U curve of 4, illustrated in A, gives the relationship between the depth of the scene point and its cock value of a camera. The latter increases with the depth of the scene point. When cock reaches its limit, cock asterisk, the point can be assumed to be at infinity. The relation between the out-of-focus blurriness and the distance UN, 4 in the pixel domain, where UN minus focus equals 1000 mm, f equals 50 mm, n equals 5.6, d equals 52.6316 mm, 0.0061 mm per pixel, and cock asterisk is 38.5184. A. Plot off cock versus U, the depth. The limit off cos is denoted by cock asterisk. In the blurring process, the dotted point is moved along curve A. In the deblurring process, the point is moved along curve B. B. The derivation of curve A. When U approaches, the blurring process fails to estimate the depth. When U is close to the focal plane, UN minus focused, the deblurring process fails in the area. Let cock be the blurriness of a point. A blurring operator can be defined to add an increment of blurriness to the point to obtain a new blurriness cock plus delta cock, with delta cock greater than 0. This can be regarded as increasing the depth of the point by moving it along the cock versus U curve toward the right endpoint of the figure. If the blurring operation is applied repeatedly, the blurriness can reach cock asterisk and the point is at infinity. If the increment in the blurriness of a point to reach cock asterisk can be determined, we can convert this increment into the increment in depth by referring to the curve, cock versus U, in A, and derive the true depth of the point. However, as shown in the curve U cock of B, a small increment in blurriness close to cock asterisk yields a substantially large increment of depth. This means that the depth determination close to cock asterisk is relatively unstable and inaccurate. On the other hand, the deblurring operator is defined to reduce the blurriness of the point to obtain cock minus delta cock. If a deblurring operation is repeatedly applied to a point, the latter will become sharper. The deblurring process gradually reduces the depth of the point by moving it along the cock versus U curve toward the left endpoint, corresponding to move the point to the focal plane or be in focus. If the decrement in blurriness, by making a point in focus, can be determined, we can convert the decrement to the decrement in depth of the point to the focal plane. Then, we refer to the curve, cock versus U, in A, to acquire the true depth of the point. However, as shown in the curve U cock of B, a small decrement in depth close to the focal plane can yield a substantial decrement in cock, which means that cock cannot be reliably and accurately obtained when the point moves closer to the focal plane by a deblurring operation. Since the depth estimation at large cock and the cock estimation of a point close to focal plane are unreliable, we were motivated to propose the blurring and deblurring approach that combines the differential blurring and deblurring operations to yield a more robust depth estimation of a scene point than only using one of them.